Hello, everybody. My name is Merve. So this topic will be about sludge solidification and stabilization. Let me pass. It's not working. Okay. I'll follow this content. Basically, I will explain the objective, terminology, regulatory requirements, and some test methods, treatment methods, and the construction and the closure of the west side. Let's start with the objective. As you can understand, this presentation will be about the sludge solidification and stabilization explanation. For the summary, terminological overview and regulatory requirements will be explained. Also, physical and chemical tests, treatment, construction method, facility safety, and quality control also will be covered. For the terminology part, I can explain that solidification as a method of encapsulation of contaminant material in a form of solid, which is low permeable material, and limiting the contaminant transfer by decreasing the exposed surface area, which is exposing to some sludges and contaminant materials. And we may look into the encapsulation by dividing into two groups. These are microencapsulations and microencapsulations. Basically, microencapsulations apply for the relatively fine particles, which sizes are lower than 2 millimeter. And also microencapsulations cover the waste containers, like the large part of waste particles. And on the other hand, stabilization can be explained as the process which includes both contaminant material and the reagents we use for the treatment. And we can say that it hosts the chemical reactions between them. So stabilization is the place that you see the binding of the free liquids and immobilized contaminated materials. Overall, solidification and stabilization state that cleanup methods to avoid the harmful chemicals and leaching from the west side. And there are two different approaches for implementation of this solidification and stabilization method. These are in situ application and ex situ application. In situ application, you can understand like it's happening to in situ and deal with the soils and sludges in the very place where they lay down, and mixing the reagents and contaminant materials in the site, and at the end of the treatment the materials stay unremoved. So you are implementing in the in situ. And on the other hand, ex situ indicates the excavation of the contaminant sludge from the site and mixing it with the reagents, the treatment materials. At the end of the process, you need to return the materials onto the site. And let's continue with some pictures. Figure 1 represents the X2 solidification and stabilization equipment. You can see the silos, reagent tanks, water tanks, and stacker, haulage, and other things. It's basically X2 view. On the other hand, figure 2 shows the in situ implementation of the SS treatment. This figure is just summarize the oily sludge. And you may see the figure 3, it shows that installing the ground slurry blanket to reduce the emission during the in situ SS treatment. And let's continue with the regulatory requirements. It's, for my opinion, it's the less attractive part of the presentation. It's basically
That's okay.
It's basically about which kind of requirements and specification is used for this kind of waste treatment. So we are dealing with the U.S. Environmental Protection Agency requirements, and also there is Resource Conservation and Recovery Act organizations regulations for the West, and they are grouped them into two: listed and characteristic. Listed one basically covers all type of hazardous industrial waste, and the characteristic part, it's summarized like some specific characteristic ways. So you're looking for the specific type of waste. It's not very common, and it's not very high cost you can reuse this characteristic vest according to RCRI. And they're also using best demonstrate available technology, discover a lot of hazardous waste, and according to EPA again. And there is also another regulation. They summarize that CERCLA, Comprehensive Environmental Response, Compensation and Liability Act. So according to their investigation, they're saying that solidification and stabilization type of treatment is the almost covers the 25% of the all type of the waste treatment in USA. So they are using a lot of solidification and stabilization method in USA, according to their explanation.
Yes, there are lots of varieties, yes.
Yeah. Let's continue with the physical and chemical tests according to this regulatory compliance. This is actually very deep topic, but I would like to just summarize as I can do.
Okay.
Physical test covers, you may summarize with the 5 main topics: index properties like the particle sizes, density tests, permeability tests, strength tests, and durability tests, which are very similar with the concrete implementation, and they're actually using the ASTM regulation by implementing this testing. And some ASTM regulation we are using also concrete. They are looking forward this kind of soil-like material. They are covering like the cement-like tissue material. So you can use concrete test methods into these physical tests. So we are saying that physical tests you can implement after and before of the treatment. But when you look at the chemical tests, it is actually about the after treatment. So you are looking the performance of your treatment in the chemical testing. You are like implementing the leaching test. But normally leaching tests are under the chemical test, but I would like to give another topic because it has also subtitles. And leaching tests basically used to assess solidification and stabilization process. So how much you improved your soil after your treatment, and it's conducted on the laboratory environment. And leaching test, it's included 3 main topic: column leach test. Column leach test is actually conduct in predetermined density. So you are taking a predetermined amount of soils and putting into container, and this material is also pulverized, so it's very fine, and you are implementing a leaching solution into that with a constant flux, and you are looking for the how much leaching it's seen in that test. And also extraction test, which is conducted in the acidic and neutral leaching solutions. Again, they are using the pulverized and grinding vestes. It's very short-term test. You can just take the results after extraction test. And these tests are mostly used as to simulate the worst scenario, because the larger surface area which is exposed to leaching solution, that because of the crushed vast material structure. So you are using pulverized and grinded materials. That means you have more surface area. So it's actually implementing the worst scenario. These also have some different type of subtitles, but I can summarize that the difference between these extraction tests are basically using the different leaching media, like from the deionized water, the different strength acidic solution they are using. Also different particle size of crushed materials. So also duration or the extraction type of the process. And the final leach tests are implemented in the monolithic, so large amount of vest, and instead of the pulverized vest. So we can evaluate it under 2 circumstances, and static and the dynamic conditions. I would like to just stop here because it's deep and confusing topic. So let's continue with just the treatment methods, more funny. Treatment methods. Before that, there are different type of treatment methods used in solidification and stabilizations. But to implement this treatment method, Sharma, which is very useful book I use in this report, offered that you need to use treatment if the waste does not pass the paint filter test. There are different type of tests, paint filter and the liquid release test. And Sharma offers that if paint filter test and the liquid release test is not, successful, you need to use the treatment methods. So what kind of treatment methods we can use? First of all, I would like to talk about the biological treatment methods. Hocam 1 dakikadan az süre var yalnız şu an.
Biliyorum, önemli değil. Sen biterse ben tekrar seni bağlayacağım.
Tamam. Okay guys, biological treatment methods, which is actually related with my thesis topic, so I can explain like that. It is about using microorganism in order to decompose organic waste into a non-hazardous form. So basically you are using like bacteria or other microorganism to decompose the waste. But it also have limitations, like some toxic waste may also be toxic for the microorganism, because they are also alive materials. So you can use activated sludge, trickle filters, aerated lagoons, or waste stabilization ponds. Also, you can use microbial induced calcite precipitation bacteria. You can see the figure 4. It is brand new article. I just found it, and it's showing that the first part is the bacteria before the treatment, and the second part shows that bacteria covered by the lead material. So it says that solidification is successful in that kind of organisms, because it just collected all leads around it, and it solidified and stabilized that around it. But it also has some drawbacks, the cost, labor intensive works, but it's also can be successful type of the treatment processes. And second one is chemical treatment processes, which is actually very common one, and it's basically
much more easy one, actually. This is the reason, but actually this is
we are continuing with the chemical treatment.
Yes.
As we say,
actually I am mentioning this. Actually, this is a much more easy process.
Mm-hmm.
But one of the major problem is this is the most hazardous one.
Yes.
So actually it's a biological treatment process, much more actually suitable for our case.
Mm-hmm.
But you know that the much more easy and cheaper one is selected as a general. Okay, then go on.
Yes. So as you say, this is the most common and the most easiest one. We can examine that as under the two topics, stabilization and solidification. Yeah, these are the main topics, but they are also examine this chemical treatment process under these topics. And in that treatment process, stabilizations converts the toxic into a stable condition to prevent the leaching by pH arrangement, like we offer using the acidic solutions, the different type of the pH materials, right, the reagents. Also you may use the digestion of the organic sludge, like the microorganism. And on the other hand, there is solidification that converts the waste into a solid block by chemical fixation. I will explain this later. And it's basically a bonding between the waste and the solid matrix, and also by the chemical encapsulation, and which is the waste particles surrounded by the solidification agent. And
similar to the biological, but as a chemical.
Yeah, it's just chemical version of that. And there are two last treatment methods: liquid solid separation process and thermal treatment process. It's liquid solid separation process is basically using the rotary drum vacuum filter. It's similar to cement production. Actually, you are using just rotary, and you are using a belt filter filter press, and after that you just collect the material into a unit like the sand drying bed, and you can see the according to maybe density, I'm not sure, but according to their density, let's say,
Yes.
their separation.
Yes.
And the last one, thermal treatment process, which is basically involves the incinerating the hazardous waste in some units like the similar the before, such as rotary kilns, multiple hearth furnace, or liquid injection system. And this figure simply demonstrate the sludge incineration. You can see the inerts and most just sludge feed is coming through, and you're using incinerator, and you are having the stuck gases, and in the process it's actually various organic are fully oxidized, and all organics are eliminated. It's finally, of course, because of the burning out, all pathogens are destroyed. But some specific materials can cause some specific problems, like the air pollution, because you are using some toxic materials and they are producing off gases. And also, interestingly, I surprised when I learned that corrosion can be seen in units. Like if you are using the PVC material, polyvinyl chloride, it's formed hydraulic chloride at the end of its process, so it causes corrosion in some units, and it
Yes.
also has some health issue for the human being because of the dioxide it produces.
Actually, for the landfill site, is a thermal treatment, thermal decomposition also one factor, but we are not generally not acceptable because of that reason.
Yes, yes, exactly. It's mostly harmful for the environment.
Yes.
And you may see the lead contamination before we solve the via microorganism. They are covered by leads, and in that process they are using chemical stabilization. It's a battery recycling site, and they're just mixing them. You may see the chemicals and the sludge or stock, what you can call, and they're just mixing the chemical and they're stabilizing the lead material. And
Okay.
that solidification and stabilization methods, and we can summarize them into two topics generally: sorbents and encapsulating agents. Sorbents, which is solid material, are used to soak up all free liquids. So this process is called sorption, basically. And we are using like activated carbon, various form of gypsum, and anhydrous sodium silicate, clays, zeolite, some natural pozzolans. This kind of material can be sorbents. The most suitable sorbents are accepted as the non-biodegradable and non-reactive materials. For example, we are using fly ash for this process, and we are using, gypsum, this kind of process. And also there is encapsulating agents. These are basically used to enclose the pollutant materials in two types: microencapsulation agents, uh, which are indicated the relatively large quantity of waste by bonding with an inert jacket. So how could I say that? They are covering with the inert material. And
Yes. Turns to the anhydride. From the gypsum, turns to the anhydride and
yes,
soak up all free liquid. It turns to the another integrants. Yes.
yes, they basically stabilizing.
Yes, of course.
And microencapsulation agents, we can refer them like the treatment for the materials between the 50 micron to 3 millimeter, with some subtitles like the thermoplastic microencapsulation method, or fly ash lime techniques, or Portland cement techniques. These are also microencapsulations methods. And the
We are
final,
using these methodology also weak clays. Actually, this is something similar to that. Okay, yeah, this is stabilization methodology. Is a actually is a, or the, there's a chemical reaction between each other related about that. But the encapsulation is the actually the similar methodology. Agent is encapsulating agent is a similar methodology. That's right. Good.
exactly. And this figure, as a representative figure, you can see the solidification and stabilization process. It's basically this, guys. You are using like think the auger. It's not have to be auger, but you are just mixing the binding agents and the wet contaminated solid, and you can use the auger to mix them, or another type of the way, like the a real example, excavator. They are just using the excavator, mixing the Portland cement, like the lead contaminate soil again, or debris. Also, bucket mixing, hydrated lime with the oil waste. You are basically mixing the contaminations and the reagents. What kind of you want to
We are
use?
using the wet mixing, or you can also use the dry mixing. Because on the right hand side, I am
Yes.
seeing the right, but after extracting water, I guess.
Yes, exactly.
It is difficult
For
to.
example, to stabilize or have the solidification for the Portland cement, you may use the water to, stabilize it by causing a reaction between them.
Yes. Yes. Okay.
And finally, construction methods. It covers the specifications required for the solidification and stabilization construction of the vest. But exactly, I couldn't find any certain specification for construction of vest, but there are some evaluation methods for the performance evaluation or testing programs. And they are looking for leachability, physical stability, reactivity, biodegradability, and the strength and durability of the solidified and stabilized vest. After the treatment, you are just checking if your treatment is, successful, like in terms of the
Yes.
reachability or reactivity. It's just about that. And but by using that, they're offered that to check your results. You may use a pallet scale test methods. So they're offered to use the pallet study, uh, like mostly covering the safety issue, like your
You know, as a material itself, is yes,
I'm listening, sir.
yes. As a material itself, if we are mentioning the sludge, you know, the construction methodology is a difficult issue to people when you are operating this issue. But actually, we are is a very suitable method. This method may be suitable for the construction.
Yes, yes. And the final one
Okay then.
is about safety, quality control, and the closure. So basically, safety is about the site personal protection, like by using personal protection program, like health and safety training, or also uh, protection of the environment by concerning the like mitigating the organic vapor from the west side, or separate of the contamination or dust production. So you are using massive amount of mixing. This kind of mix cause dust. So it's also concerned about that. So each project is unique, and that means all need their own safety programs. So, and this problem can be solved just the beginning of the project by the design process or pilot studies. Also, quality control can be examined by considering two issues: sampling and testing. They're offering that using sampling, you can use again concrete ASTM specification. These are for
Yes,
you
yes.
fresh one and hardened concrete. So you can use just fresh west sampling for ASTM similar specification, and also cured waste sampling for this specification again. And at the end of treatment is done, of course you need to close the site. You need to make a closure after cleaning the site and the decontamination of the all equipment you use. As a final, I would like to show just one thing, guys. This is why I add to the end, because I just recently find that I was looking forward any example from Turkey I can give
Yes.
about the solidification and stabilization topic. But to be honest, there is not so much research about that in Turkey. And you may
Yes.
see that from the figure. We are using mostly incineration and landfilling. Landfilling, it's different topic, totally different topic. We are just dumping the waste. But on the other hand, incineration means that actually we are choosing the one of the most hazardous, one of the most harmful methods of this kind of treatment, like the thermal treatment process. So Turkey has not so much research or study about that. This is our current situation. So thank you for your attention. This is my slide, and